all the interior angles are equal. The angle of incidence is 30 degrees. We have to study and calculate R1, R2, and E when the refractive index of the prism is 1.5. I want you to look at it. Think through it. Okay, try solving for just maximum 6 minutes. Then I come in. Think through how you can determine R1, R2, and E when you are given a refractive index of the prism to be 1.5. Just think through this for 5 minutes. Five minutes is over. So, a queer what Elena, Ishra, Janice, Josephine, Kenneth, and Oye. Let's see what to do in a situation like this. We are first to determine R1, and R1 is the first angle of refraction with respect to the first refracting plane AB. R2 is the second angle of refraction with respect to the second refracting plane AC. One thing that I know is that the angle of the prism A is equal to R1 plus R2. Now I have A. But because I don't have any of these, I cannot find the other. A is 60. All right. How do I determine R1? At least I know the refractive index of the prism. I also know the angle of incidence. And so I can find R1. So using absolute refractive index of this Snell's law, sine of I over sine of R1. Okay, the absolute refractive index is 1.5. It's equal to sine of I, which is 30, over sine of R1. Therefore, when I make sine R1 the subject, I have sine of 30 degrees divided by 1.5. Now sine 30 is 0.5, half. So I have 0.5 divided by 1.5. Take this ratio for me. 0.5 divided by 1.5.
0.33.
So this is equal to, okay, 1 on 3. So 0.333333. That recurring one. Therefore, R1 is equal to the sine inverse of 0.3333. And that is equal to, what's the sine inverse of that decimal figure?
19.27 degrees.
19.27
degrees.
So this is the value of R1. Having had R1, R2 is simple. All right. And so using A is equal to R1 plus R2. R2 would be equal to A minus R1. A is 60. R1 is 19.27. Therefore, yes, subtract and tell me the value of R2. 40. 40 point. Hey,
40.73.
please give me a minute to pick something from somebody. I'm coming. Okay, so we have R2 also to be equal to this. We are left with E. How do we find E? Yes, for this one, somebody should help me. How do we determine the value of E? Anybody to help? Equia is here. Equia Watsma, Eliana, Ishra, Janice, Josephine, Kenneth, Demaris, and Uye. I want somebody to help me find E. Yes, any idea? Any idea? Hey, Asura Teddy, Josephine, Equia. Okay, Josephine. Josephine.
Yes, Mr. Idea.
How do we determine the value of E? Can I get ready? Any idea, Josephine? Yes or no? Josephine, yes or no?
No, please.
Kenneth, any idea?
Please not yet.
Equia Watsma. Any idea? Equia, your line is breaking. Oh. Equia Duma. Or no idea?
No, sir.
Okay. All right. Then let me come in. Equia Watsma, relax. You see, I can reverse the path of the ray. If I'm going from left to right, the refractive index is sine I on sine R1. If I reverse the path from right to left, then this angle becomes the angle of incidence. So, assuming this is X, then I can say that the same refractive index, because I'm still moving from air to glass. Okay, so this would be sine of X over sine of R2. if I manage to find x, I can determine e, because this is the second normal. The angle from this to the prism is 90. So if I find x, I just subtract x from 90 to get e. So you can determine it by reversing it. Still, air to glass, it is absolute refractive index. So n is still 1.5. But this time the angle of incidence will be this angle. Because we are reversing the path, this will be the incident ray. So that it will be this angle, sine of this angle over R2. Please, is that okay? And I told you this, I told you about this last time. So quickly, let me see. Let's find x. Then we use x to find e. Make me proud. Demaris, I'll be interested in your answer for x. So I'll call you. Okay. So x, therefore, e is equal to 90 minus 78.17, which is 11.83 degree. All right. There's another way out. But okay, we can use the other way when we found the total deviation. So I think this, for now, this is it. When we go through the total deviation thing, and the other way I'm trying to talk about is that total deviation T is given by I plus E minus A. So we can also find, but this E refers to the angle of emergence, which we have represented as X. So you can use this concept. If you know total deviation, I and A, you can find X. Once you have X, you subtract X from 90 to get E. So that's the other way out. Please, is everybody okay? All right, let's continue our journey on this. We derived the equation, and so there is another important aspect which we have to go through under refraction of light in triangular prism. Today we have to also begin with lenses. So let's quickly finish. So the question you just solved is NOVDEC 2023. One of the questions is analyze. So under refraction of light in triangular prism, we came across this is the normal, another normal, what you just solved or what we've just applied. N1, N2, angle of the prism. So incident ray, it will deviate through this This is the refracted ray, and then this is the emergent ray E. R1, R2. And so we derive that the angle of the prism A is equal to R1 plus R2. Then we also determine the total deviation when we extended these lines. The incident and then the emergent ray, giving us this angle, which we are calling as the maximum deviation, D maximum. And we came to the conclusion that D maximum is equal to deviation D1, D2. So D1 plus D2, D1 is I minus R1 plus D2 E minus R2. This we joined to have I plus E minus R1 plus R2. So I plus E minus A is equal to the total deviation D maximum. All right. So these are the relations we derive. Now, let's come to another important application. Now, if we vary the angle of incidence progressively, starting from a very small value, and then we increase it gradually. Please note that when the ray incidents along the normal, the moment you incident a ray along the normal, meaning the ray is perpendicularly to the refracting plane, maybe AB, the ray goes undeviated. The path, so when a ray of light is incidented perpendicularly to the surface, the ray goes undeviated. The path of the ray will never be deviated. So it will go through this and then hit here. Okay. Here, it means that the normal is along this. Now, when it comes to the surface AC, when the ray gets to the surface AC, then because when you draw a normal, this time it is at an angle a certain angle. This is R1 or R2. R1 is 0, but R2 has a certain value. When it comes here, then because it is coming out of glass to air, then it will be deviated. Is somebody okay here? Please, are we okay? So when it comes into contact with, as at when it is emerging out of the block, then it is deviated because this time it is not intersecting on this surface at an angle of 90. So it will be deviated. But before, because it hits AB at 90, the ray is undeviated. It will be deviated when it is acting at any different angle. Then this becomes the angle of emergence, E. Okay, so when you use this relation that A is equal to R1 plus R2, R1 is 0 because the ray never got deviated. The angle of incidence I is equal to 0, and therefore R1 is equal to 0. This becomes R2. So A therefore is equal to R2. Please, are we okay with this explanation? Are we okay here? A is equal to R2 because R1 is 0, I is 0, R1 is also 0, but this is R2. So if this is 0 and we have this situation, then A is equal to R2. If we are to calculate for the total deviation in a situation like this, then total deviation D is equal to I plus E minus A. I is 0, okay? E, then we have found A. A is equal to R2. So when you know A, which is equal to R2, you can always use this to find the total deviation, how the ray got deviated. And that will be equal to E minus A, the angle of emergence minus the refracting angle of the prism. So this is what happens when a ray is incidented perpendicularly to one surface. All right. So let's then continue with our discussion, if you are okay with this. So if the angle of incidence is increased gradually, we are increasing the angle of incidence gradually. Normal is here, and I is being increased gradually. You realize that as angle of incidence is increased gradually, you have the total deviation, okay, dm. The total deviation also decreasing. So whilst I increases, the total deviation dm also decreases. Please don't forget that the total deviation we are referring to d is equal to I plus E minus A. So as we increase this gradually, then the total deviation within the prism also gradually decreases. Now this trend would continue till a certain value of a certain value of angle of incidence. So a particular angle of incidence will be reached where the total deviation begins to increase instead of decreasing. Please, are you here? Are you following?
Yes, please.
So the trend is that as we increase the angle of incidence gradually, we realize that the total deviation dm also decreases. So in data wise, this is like this I dm. So as we increase I gradually, maybe from 5, 10, 15, 20, then this also begins from a larger value, maybe 50. Then when I is increased to 10, 45, 15, 40, 20, 35, there will be a particular angle of incidence. Maybe 25. Then instead of this to continue decreasing, no, it will rather increase. So at 25 degrees, instead of D to continue increasing as to continue decreasing as the trend, this is 35. Then it will rather begin to increase. So 35, then we'll come back to 40, 20. This is 30. Then we'll have 45, 45, 35. Then we have 50. So it has been reversed. As this increases, this has to decrease. But there's a particular angle of incidence which will change the trend that dm begins to increase instead of decreasing. And this angle of incidence gives us what we call as the minimum deviation. Okay, this is the minimum deviation. 50, 45, 40, 35. Oh, so this is the angle of incidence. So 35, then 30 degrees. Then from 30 degrees, it begins to increase. So 35, 40, 45. So this angle becomes the least or minimum deviation. Now at that angle, or at this angle we are calling as the minimum deviation, something happens. Something happens. So at the minimum deviation, we realize that Josephine, are you there?
Yes, please.
At the minimum deviation, this is when we realize that the angle of incidence, I, is equal to angle of emergence, E. So I is equal to E at the minimum deviation. And we said that at the minimum deviation, the incident ray passes through the prism symmetrically. Take note of the key terms. At the minimum deviation, the incident ray passes through the prism symmetrically. And angle of incidence is equal to the angle of refraction, emergence. I is equal to E. That's one. Two, at the minimum deviation, I is equal to E, and the first angle of refraction, R1, is also equal to the second angle of refraction, R2. So it means that at the minimum deviation, we don't have R1, we don't have R2. All that we have is R, angle of refraction, because both are equal. At the minimum deviation, I is equal to E. So it means all that we have is the angle of incidence. So these are conditions which occur when we obtain that minimum deviation. I is equal to E. Angle of incidence is equal to angle of refraction. R1 is equal to R2. And they are all equal to one angle of refraction, R1. So if this is what happens, then look here. We earlier saw that A is equal to R1 plus R2. Then it means that A will just be equal to 2 times R, because R1 is equal to R2. So it's like either 2 times R1 or 2 times R2. Okay, so all that we have is an angle of refraction. We don't have 1 and 2. We only have an angle of refraction. So A is equal to 2R. The next thing is that total deviation, dm, is given by I plus E minus A. It also means that at the minimum deviation, so instead of total dt, because we are at the minimum deviation, we write d minimum here. Because this time it's not the total, but we are at that minimum deviation, dm. Because I is equal to E, and they are all equal to I, we have 2 times I minus A. So D minimum is equal to 2 times I minus E, minus A. Now, we can use these conditions which prevails at the minimum deviation, also to find the refractive index of the prism. And this is it. We are saying the refractive index is equal to sine I over sine R. Now, at the minimum deviation, when we make I the subject from this, we have 2I equal to D minimum plus A. divided by 2. So I is equal to D minimum plus A over 2. That's the expression for I. If we come here, we also have R to be equal to A over 2. So when we substitute this, whatever we've had for I and R, into the refractive index equation, we have N is equal to sine of I is now D minimum plus A over 2, all divided by sine R. R is this, A over 2. So this becomes an expression for the refractive index of the prism at minimum deviation, where D minimum is the minimum deviation angle, A is the angle of the prism, and so on. Okay. Please, are we okay with this?
Mm.
Any question? If you need further clarification or if you have any question, you can quickly ask to be taken through. So this expression becomes the refractive. We use this expression to determine the refractive index of the material used as a prism. Okay, so this enables us to find the refractive index of the material used as a prism. So whatever we get, if the prism is made of glass, then N here is the refractive index of the glass. If the prism is made of plastic, N becomes the refractive index of the plastic. But please, this is not different from using Snell's law, sine I on sine R. The only difference is that we are using the condition of minimum deviation to also find the refractive index of the material. Okay, this is without minimum deviation. This is at minimum deviation, and we can also use the conditions which prevails there to find the refractive index of this and get the same value as when we have used Snell's law. All right. Now let's plot a graph of what happens at minimum deviation. When you plot a graph of the angle of incidence against deviation, what happens? There is a graphical representation of as we vary the angle of incidence to get to the minimum deviation. So we earlier saw that as I increases, that is how we obtain the minimum deviation. We gradually increase I So as I increases gradually, the total decreases. Then a particular value of I gives us a point where instead of D increasing, D will now increase. So there is a particular angle of minimum deviation. Okay. So when you plot a graph of I, because the deviation depends on the angle of incidence. So I is horizontal, and then D is a vertical. Okay, so independent variable and then dependent variable. As I changes, D would also change. So it means that D depends on I. So if I is increasing, then when I is zero, there wouldn't be any deviation. When a ray is perpendicular to the normal, the ray does not deviate. So when I is zero, there wouldn't be any deviation. But when I increases, then I will start from a maximum value. Please get the difference. So when I is zero, there wouldn't be deviation. So this ray will never will never intersect the vertical. Now, as I increases, D would also decrease. Let's assume this is here. This is here. Now there will be a particular value of the angle of incidence where instead of this continuing to decrease, it will now begin to increase as we saw, meaning we've attained a certain condition. So as I increases, we have D this time increasing. As I continues to increase, the deviation is increasing. So when you join these points, you have a graph which looks like this. You have a curve. And this point, when you trace it to the horizontal, don't forget the horizontal is I, angle of incidence, gives you that particular angle of incidence, which gives us the minimum deviation. So the vertical must correspond to the minimum. So I is that particular angle of incidence, which sets us to the gives us the condition of minimum deviation. So this is minimum deviation, whereas this is that angle of incidence which since enables the ray to pass through the prism symmetrically. Out of which we have that then angle of incidence equals angle of emergence, R1 equals R2, and so on and so forth. So this is deviation against angle of incidence graph, and then the condition for the minimum deviation. So at this I and this angle, we have this condition. So at D minimum and that angle of incidence I, we have I equal to E, then R1 equal to R2. And we say that the ray passes through the prism symmetrically. All right. Let me look for a question under this and then go through it with you, at least to see how this is applied in solving questions. A minute. Okay, are you ready? I'm reading. I'm reading. If in a prism, the angle of the prism is 60 degrees, and the refractive index is 1.52, and the refractive index is 1.552, calculate the minimum deviation of a ray of light that passes through it. If in a prism, A is 60 degrees and the refractive index is 1.52, calculate the minimum deviation of a ray of light that passes through it. A second question. A second question. A ray of light experiences a minimum deviation. A ray of light experiences a minimum deviation when passing symmetrically through an equilateral triangular glass prism. When passing symmetrically through an equilateral triangular glass prism. Calculate the angle of incidence of the ray if the refractive index of glass is 1.5. calculate the angle of incidence of the ray if the refractive index of glass is equal to 1.5. All right, so try the first one. The first question says that if in a prism, A is equal to 60 and the refractive index is 1.52, calculate the minimum deviation of a ray of light that passes through it. And the second question is saying that a ray of light experiences a minimum deviation when passing symmetrically through an equilateral triangular glass prism. Calculate the angle of incidence of the ray, given that the refractive index of glass is 1.5. So attempt the first one and let's see what you can. Yes, what did you get for question 1? What answer did you get for the minimum deviation? Whoever had it should share your answer, not how you did it, but your answer with us. Akuya, what did you get? Akuya, are you there? Oye? Oye? Hey,
Mr. Edua,
are you there?
Mr. Edua, please, I got 38.92 degrees. Yes,
Okay. Josephine, what did you also get? Kenneth, what did you get? Let's sample
please.
some of the values.
38.92 degrees.
30 what?
38.92 degrees.
Okay. So the angle of the prism is 60. The angle of the prism is 60. A is 60. And the refractive index is 1.52. Then we have to calculate the minimum deviation of ray. Okay. So once there is the use of the word minimum, then we are at that point. How does refractive index relate to minimum deviation? That's a sign of minimum plus E over 2 all divided by sine of A on 2. So 1.52 is equal to sine of the minimum deviation is what we are looking for. 60 on 2 divided by, that's a sine of 60 on 2 sine 30. So we have 1.52 times sine of 30 equal to, let me break this down, 1.52 times sine 30 degrees equal to sine of the minimum deviation which we are looking for plus 60 all divided by 2. Okay, so sine 30 is 0.5 half. So 1.52 times 0.5 is equal to sine of all these. And please, this is the same as even I. Whatever is in brackets is I. Angle of incidence. So I is equal to the sine inverse of 1.52 times 0.5. And what's that? Give me the sine inverse of this thing. All this within the brackets. Yes. What's the result? Again?
0.76.
So sine inverse of 0.76. Yes. What's the answer?
49.46.
Okay. This is 49.46. So it means I, okay, 49.46 degree. So I, however, I is also equal to whatever is within the bracket here. So we have minimum deviation plus 60 over 2 is equal to 49.46. Therefore, make the minimum deviation the subject is equal to 2 by 49.46 minus 60. Okay. So do the multiplication, then subtract 60 from that. And you have 38.993 degrees. That's what it is. All right. Then the second question. Did you attempt the second question? Class, did you? And anybody? If any one of you tried, share it with me. Kenneth, did you agree and co? Give me feedback. Yes or no?
No, please.
So a ray of light experiences a minimum deviation. Okay. So usually the question is that what informs that we are at the minimum deviation or not? The question must say it. Okay, so the question can clearly state that at the minimum deviation or the ray passes through the prism symmetrically. These are the statements which would inform you that we are at the we are talking about condition of minimum deviation when the ray passes through the prism symmetrically. All right, so a ray of light experiences a minimum deviation when passing symmetrically through an equilateral triangular prism. So once we are told that it's an equilateral triangular prism, then it means all the interior angles of the prism are equal. All the interior angles are equal, 60 degrees. So straight away A is equal to 60. So of an equilateral triangular prism, calculate the angle of incidence of the ray when the refractive index of the glass is 1.5. So the refractive index is 1.5. Okay, and we are to calculate the angle of incidence. We are told the ray passes symmetrically through this, meaning we are at the minimum deviation. At the minimum deviation, what happens? At the minimum deviation, we have A equal to 2R. So this alone should tell you something. A equal to 2R. Therefore, R is equal to A on 2. A is known, 60. So it means that R is 30 degrees. At the minimum deviation, the refractive index is sine I over sine R. But it is under that special condition that we say that, okay, at that condition, I is minimum plus A over 2 over sine of A on 2. So what I have done straight away tells you that, oh, okay, then A on 2 is 60. Because at the minimum deviation, don't forget from this equation, A is equal to 2R. It is this R that is being made as a subject and brought here. So what we have is just the same as this one. Please, are we okay?
Yes, please.
This part is equal to I. So you don't need this formula. All that you need is that, yes, this is N is equal to sine I over sine R. And R at minimum deviation is equal to A on 2. So you have the refractive index 1.5 equal to sine I over sine of 30. Therefore, sine I is equal to 1.5 times sine 30. Sine 30 is half. So 1.5 times 0.5. What is 1.5 by 0.5? 0.75. Therefore, I is equal to the sine inverse of 0.75. What's the sine inverse of 0.75? And this is 48 point. So simple. It's not a difficult concept at all. Not really difficult. Okay, so Dimaris, are you okay?
Yes, please, Mr. Yeah.
Adwa, Otubia, Ishira, are you all fine? Let me give you one question to try. And this one, you do it as an assignment and then send to me. But let me check the time now. It's 8:42. Okay. So get ready and listen to this assignment. In fact, this one, thinking must go into it because it's a bit brainy. A ray of light passing through a prism, a ray of light passing through a prism having refractive index equal to square root of 2, root 2. A ray of light passing through a prism having refractive index equal to root of 2 surface minimum deviation. Its surface minimum deviation. It is found that the angle of incidence it is found that the angle of incidence is double the angle of refraction within the prism. It is found that the angle of incidence is double the angle of refraction. What is the angle of the prism? What is the angle of the prism? So here, the question is looking for the refractive or refraction angle of the prism. So it's looking for this angle, A. They're looking for A. I'm going over the question again. A ray of light passing through a prism having refractive index root of 2 surface minimum deviation. Its surface minimum deviation. It is found that the angle of incidence is double the angle of refraction within the prism. What is the angle of the prism? Okay. Question 2. Question 2. A ray of light falls on a glass plate. A ray of light falls on a glass plate of refractive index 1.5. A ray of light falls on a glass plate of refractive index 1.5. What is the angle of incidence of the ray? What is the angle of incidence of the ray the angle between the reflected if the angle between the reflected and the refracted the angle between the reflected and the refracted rays is 90 degrees. A ray of light falls on a glass plate of refractive index 1.5. What is the angle of incidence of the ray if the angle between the reflected and the refracted rays is 90 degrees? Because you've done total internal reflection, this idea of reflected and refracted must be familiar to you. Okay. So what is the angle of incidence of the ray if the angle between the reflected and then the refracted rays is 90 degrees? This is the problem of the day. All right. So
Mr. Jeff, the last
Mhm.
sentence again.
The last sentence is that what is the angle of incidence of the ray? What is the angle of incidence of the ray if the angle between the reflected and the refracted ray is 90? Let me sketch something for you just to help you apply better. So a ray of light falls on a glass plate of refractive index this. So there's a glass plate. So this is glass. The ray is from air. Don't forget we were given the refractive index and this is absolute. So because we'll be drawing angle of incidence, there should be a normal. This is the angle of incidence, I. We don't know. But whenever a ray hits a transparent material, part of the ray is reflected. So this is a reflected ray. Then part of it will be refracted. How will this ray be refracted? How will it be refracted? How will it be refracted? Oh, the ray is entering a denser medium. Let's hurry up.
Towards the norm.
So it will be deviated towards the normal. This is the angle of refraction. So this is the refracted ray. This is the reflected ray. And we are told that the angle between the reflected and then the refracted ray is 90. That's all. So we use this idea to find the angle of incidence I. That's the problem of the ninth. Okay. So you start work. You start work. Answer. We have 8 minutes to 9. I'm here with you. Think through this. Start answering question 2. And then you would answer the question 1 later and send. Some of you have joined your bets ahead of time. So start this one. I'm with you here. We will close at 9. So